Yes, Assalamualaikum warahmatullahi to our lecturer, Mr. Zarafi. So today we will be presenting our group assignment. So our group assignment entitled The Variable Speed DC Motor for a Small Scale Model Application. So firstly, introduction.
So my name is Hani Hamizan Hilmi bin Bunaim. My metric number is CE190079.
My name is Mohammad Hakimi bin Othman. My metric number is CE190092.
My name is Mohammad Iskandar bin Batisah. My metric number is CE190083.
My name is Naim Rizuan bin Zaid. My maintain number is CE190070.
And my name is Muhammad Haekal bin Shahriman. My metric number is CE190090.
Okay, so for the introduction, a remote control vehicle is defined as any vehicle that is teleoperated by means that does not restrict its motion with an original external to the device. For our project, we have to design a small scale car model. We develop a variable speed DC drive for a small scale car model application using input DC with some specification such as using Arduino microcontroller, motor driver, and IoT based communication. We also use Arduino Uno as our microcontroller, and we apply pulse width modulation technique in Proteus software to determine the fundamental and design a closed loop speed control for the system. Next.
So for the problem definition, there are a few issues were discussed to develop a variable speed DC drive for a small scale car model applications to maintain the efficiency, long life, and its quality. In real world, the maximum speed of the motor applications is not used totally, where it may be used only 50% of its speed. The easiest way to adjust the DC motor is using a variable resistor, as it can measure the variable resistance in series with the motor. This method usually will give some disadvantages, such as the resistor will release wasted energy as it will not be functioning on few device like microcontrollers or any digital equipment for the automatic DC motor speed control. Next.
Okay, for methodology, I will explain about this. This chapter will explain about the method that has been used to complete the construction of the prototype through research, which mostly involve drive system development. Drive system development in this project started by understanding DC motor drive, and controller. So then the component is assembled, and the prototype has a few tests to make sure it has a small scale car model application. There are a few components that we use to develop our drive system. The specification of component being used is we use Arduino Uno. So its operating system is 5 volt, while the input voltage is between 7 to 12 volts. For for analog input pins, which is 6, A0 to A5, and digital input output pins have 14. So the next one is DC motor. So DC motor we use standard 130 type DC motor operating voltage, which is around 4.5 volt to 9 volt. So in this project, recommended rated voltage is 6 volts. So current at load is 70 milliampere. That's for max, and no load speed is around 9,000 RPM. So the next one is L293D. It is can be used to run two DC motor with the same IC. Speed and direction control is possible when we use this. So the motor voltage for VCC, which is VS, is around 4.5 volt to 36 volt. Okay. Next, for potentiometer, as we know, potentiometer we can adjust the resistance. So it is used to control the significant amount of power, and control input for electronic circuit. So the last one is for push button to connect and disconnect the circuit. For the flowchart, flowchart on this project is used as a guide to complete the project. First of all, the project started with do a research and a system drive development. After stimulate the project, we need to test and troubleshooting before continue with presentations. That's all for me. Next.
So for the block diagram, we have input which is 10 volt DC voltage. After that, microcontroller, we have three condition which is C for clockwise and press A for anti-clockwise and press S for stop. So the program will give order to PWM which is pulse width modulation, and PWM will give order to motor to move either clockwise, anti-clockwise or stop. So the motor will give position feedback to the microcontroller about the motor, about the condition of the motor. That's all for block diagram.
Okay, for circuit diagram, one Muhammad Haekal will explaining about this.
So next I'm going to explain about the circuit. So basically there are several components we use in the circuit, which is optocoupler, relay, Arduino Uno, transistor NPN, diode, light dependent resistor LDR, external junction field effect resistor JFET, and 9 volt DC motor. So okay, next I'm going to explain about the PWM signal. In this project, we use light dependent resistor to regulate the speed of the motor. The light dependent resistor is a sensor that varies the resistance to light falling. The resistance of the LDR decreases with the increasing light intensity and vice versa. The LDR gives analog output values and is connected to an analog pin on the Arduino. The output of LDR is used to monitor the speed of DC motor. There is an inbuilt analog to digital converter ADC present in the Arduino Uno. With this feature, the output of the LDR, which is analog signal, are converted to digital signal, and the Arduino will analyze it, and the Arduino will generate the PWM, pulse width modulation signal, in the PWM pins. And the output signal via PWM pins will be analog signal acquired as digital signal from the Arduino, and it uses the duty cycle of the digital wave to generate the consequent analog value for the signal. So next is the circuit condition. So basically there is three command used in the circuit, which is C for clockwise, A for anti-clockwise, and S for stop. So I'm going to demonstrate how it works. So firstly, we will want to move the motor in clockwise direction. So we type C, and we will observe the motor will turn clockwise. And if we type and we press S, the clock will stop. The motor will stop moving. And if we press the A button, the motor will turn anti-clockwise. So next I will show the Arduino coding. So this is the coding we use for the simulation. So first of all, we declare the motor and the applicable item in the coding, and we declare the output and input of the system, and we declare the movement of clockwise, anti-clockwise, and stop to obtain our desired movement of the system. So I think that is all. next, we will proceed to Hakimi to explain about the discussion.
So I will explain for the result and discussion. This project can be applied in the small scale car application, which is we can control the speed and direction of the car by implemented this theory. We use the Arduino coding to generate the command. The code is written and uploaded on Arduino as microcontroller to measure the position and speed of the DC motor. A closed loop technique is implemented where the output measure speed and direction is fed back to the controller. So that's all for the result. Thank you very much.